Okay, let's just do some more examples of verifying identities. In this video, you'll see some more complicated examples as well that you should take a few more steps. So here I am trying to verify the identity cosine x over 1 plus sine x plus 1 plus sine x over cosine x equals 2 secant x. Again, usually it's easier to start with the more complicated side. So I'm going to go ahead and start with the left-hand side here and see if I can find a way to manipulate it using the identities we already know and some basic algebra to get to the right-hand side. All right, I'm just using some color to show where I'm starting so I can kind of just keep track of where I started and where I need to go. So I'm trying to find a way to get this to look like 2 secant x. Here, again, I tend to jump first. If I see things like tangents and cotangents, secants and cosecants, usually I try to put those into sines and cosines first. Again, it doesn't always work, but that tends to be my first strategy a lot of times. I don't see anything helpful here with that, so I can't do that. I don't see any Pythagorean identities yet. Be careful, the Pythagorean identities have squares in them. So 1 plus sine x is not cosine x. Be careful there. It's, sine squared plus cosine squared equals 1. So they look very similar, but they're not the same. So I'm going to go ahead and use my strategy of trying to get common denominators. So let's see if I can combine this together. I'll get common denominators and see if that works. Now, this is one denominator. It's kind of stuck together with that 1 plus sine x. So think back to your polynomials for a second here and your rationals. So I'm going to just make my LCD here. Just make a little note. 1 plus sine x times cosine x. I can't really see a way to make that any easier, so that's what I'm going to go ahead and use. So for my first piece, I'm missing the cosine. So I'm going to multiply by cosine x over cosine x. Sine x. And then for the second piece, I'm missing the 1 plus sine x. And I'm going to go ahead and simplify this. So here, cosine times cosine is cosine squared. So cosine squared x. Now here, you want to be careful. You actually have a little bit of distributing to do. So 1 times 1 is 1. 1 times sine x is sine x. On the inside, 1 times sine x is sine x. And then sine times sine is sine squared, so sine squared x. Again, I'm just going to clean this up a little bit more. So I have cosine squared x plus 1 plus, now sine and sine would be 2 sine x. And this is all over 1 plus sine x times cosine x. I'm going to keep cleaning up a little bit here. You do want to note, remember that sine squared plus cosine squared x can be simplified. So I'm just going to kind of rearrange that here. Plus 1 plus 2 sine x. Now, this right here is one of the Pythagorean identities. Sine squared plus cosine x is just 1. So this becomes 1. 1 plus 1 is 2. So 2 plus 2 sine x over 1 plus sine x times cosine x. Now here I see a 2 plus 2. Be careful there. 2 plus 2 is not 4 here. These are different things. 2 plus 2 sine x. But I can factor that 2 out. So 2 times, and then there'll be a 1 there and a sine x here. I do see that 1 plus sine x will cancel. And I'm left with 2 over cosine x. Now, this is the same thing as 2 times 1 over cosine x, right? And 1 over cosine x, again, go back to your identities here, is secant, that right there. So this becomes 2 times secant x, or finally 2 secant x. That was what I was looking for that right-hand side. This was a really long one. We're done. Even though it was a long one, we really only use a main strategy of finding common denominators. So here we really use those common denominators and then just use some algebra and kept cleaning it up and cleaning it up and cleaning it up. We did have a couple identities here that helped us, right? I did a little bit of factoring there. So just, again, some basic algebra techniques. I was able to cancel, and then I was able to bring in another identity to get back. So sometimes going back to the basics, even though they have trig involved, it is a good way to go. All right, so we're going to do sine x over 1 plus cosine x is equal to 1 minus cosine x sine x. All right, so this one's a little bit different. Again, this video has some harder ones here where the puzzles are a little bit trickier to solve. So here you have sine x over 1 plus cosine x, and then you have 1 minus cosine x over sine x. Both sides of the equation seem pretty equally difficult. So I would just pick one to start. Usually in that case, I tend to just pick the left-hand side just out of habit. But again, I try to pick whatever one seems like it's usually more complicated because usually those are easier to simplify and cancel things out. So I'm going to start with the left-hand side, and I need it to look like the right-hand side. Now here, I don't have any thing that I'm adding or subtracting, right? I know we have a fraction, but I don't have another fraction to add with. So common denominators doesn't really apply here. I can't break this down. So when you have a denominator, it's stuck together. I can't do sine over 1 plus sine over cosine. That you can't do that. I can only break it down if the numerator has the plus or minus signs in, like we saw in another example. The tip that's given here is to try to think a little bit ahead and note that you really want the numerator to be 1 minus cosine x, not sine. So the suggestion here is, well, let's try multiplying by 1 minus cosine x to kind of bring that in, right? We have to bring that in somehow. So let's try that. But you can't just multiply it on the top. You have to keep things consistent. So we multiply it on the bottom too. That way you're multiplying by a value of 1, right? Same thing on top and bottom. But we're trying to get that numerator that we're looking for. So let's go ahead and start simplifying here. So I'm going to start in numerator. I think I'm going to just leave it for right now. I guess I could distribute here sine x and then 1 minus sine x cosine x, but I don't know if that really is going to help me. So I'm just going to leave it for a second. So again, I kind of want that 1 minus cosine x there. So I'm not going to not distribute that yet. I am going to distribute the denominator though. So I have to FOIL this out. So I have 1 times 1, which is 1. 1 times negative cosine x. 1 times positive cosine x. And then minus cosine squared x. Now here, a negative cosine plus a positive cosine are going to cancel. So this becomes 1 minus cosine squared x. Now, when I start seeing squares, I kind of start thinking about those Pythagorean identities. So remember that sine squared plus cosine squared is equal to 1. So if I bring this cosine squared to the other side, if I subtract it, I see that sine squared x is 1 minus cosine squared x. So I can go ahead and make this substitution here and replace that with sine squared instead. Now, I also noticed that I can cancel one of the signs out. So think about it, right? If you had something like x over x squared, you could cancel out one of the x's, right? I'd have 1 over x left. You can do the same thing here. We can cancel out one of the signs. So I can cancel out one of the signs, and then here, this would just be sine. So this becomes 1 minus cosine x over sine x. Now, this was what we were looking for. So we are done. We were able to verify that identity there. But again, this one was tricky because there wasn't an obvious technique to start with. I wasn't able to break down that fraction. I didn't have common denominators to really work with here. I didn't have anything to factor out. So if you have nothing to really do, that's obvious, maybe try and use the numerator of what you're trying to get to, or even the denominator of what you're trying to get to make that work. So here we're like, well, I want to get to 1 minus cosine x. So let's just bring it in. And if we're going to multiply it in, though, you do have to multiply the same thing on the denominator. And we were able to get the rest to work out algebraically. All right, let's do another one. All right, so here's another one. And again, this one I clearly have a more complicated side, so that's usually the place that you want to start. So I'm going to go ahead and start with this guy here. All right, so I'm going to just start doing a little bit of manipulation here and just kind of seeing what I can get to. So let's see, usually I like to take that tangent and make it sine over cosine. I'm going to have a lot of fractions going on, so I'm just going to be careful. So that becomes sine x over cosine x. Now, don't forget, you also have your even odd identities here. So sine of negative x is negative sine of x. I'm going to make that change as well. So I have minus, right, minus, and then this becomes negative sine x. So I have sine x over cosine x. Here my negatives will cancel, plus sine x. I'm going to start by cleaning up that numerator first. We really don't like to have fractions and fractions, so I want to start cleaning this up. I'm going to not worry about the denominator just yet. I'm just going to work on the numerator. My denominator here is cosine, so I'm going to multiply this by cosine x over cosine x in order to get a common denominator there. I'm going to keep going here. So again, I'm kind of focusing on the numerator just for a little bit here. I do see that they both have a factor of sine in them. And I'm thinking about the other example we did where I'm saying maybe I can factor that sine out. So for me, that's my next step. And now I don't really see much else I can do in the numerator. I'm ready to get rid of this big giant fraction. So just be careful here. So this is our main fraction bar. Right, that's the main fraction bar. What I like to do is I like to multiply by the reciprocal. So here I'm going to multiply by 1 over 1 plus cosine x. That will cancel, you know, my two groups there. And then I'm going to multiply by 1 over 1 plus cosine x here. So I do have to be consistent when I get rid of that denominator. So I have sine x times 1 plus cosine x times 1. So that doesn't change anything in the numerator. And then over cosine x times 1 plus cosine x. Now, hopefully you're noticing that those two cosine x's will cancel. And I'm left with just sine x over cosine x, but that is just tangent. So we actually did get to what we were trying to do here. and we were able to verify the identity. So for this one here, I actually didn't really use many new techniques. I used the even odd identities here for the first time, so that was helpful. But a lot of it was really algebraic manipulation. Obviously, there's trig functions in there too. I know that, so it is a little bit harder, of course. But it's using those basic skills and building on them. So the idea of common denominators, the idea of clearing out those big messy fractions. We don't want fractions and fractions. So I was able to use the reciprocal there of the denominator to clear that out. And then things started canceling. So this one was really a lot of algebra skills that we had to recall in this case. Now, the next one I want to do in this video is going to be different. So in all the examples so far, we have been just working with one side of the equation and just plowing through, and we're able to get to the other side. In this example, this one's going to be pretty challenging, and we're not going to end up doing that here. We're going to end up manipulating both sides, but when we do that, we do it independently, not as one big equation. So what I'm going to do is I'm going to start with the left side, because for me, that seems to be the more complicated one personally. I'm going to manipulate that as much as I can, and then I'm going to kind of get stuck. So let's start and see what happens. All right, now for this one, I definitely see fractions being added. And again, I don't see any tangents or cosecants or things like that. Usually we try to put things in terms of sine and cosine. Not always, but usually that's a good place to kind of start if you don't have that yet. Everything is in terms of sines and cosines, obviously in the number one. But I do see fractions, so I'm going to use common denominators here. Now, I don't really have too much of a choice. Remember, this is all stuck together. This is one group. So my LCD is going to be 1 plus cosine theta, 1 minus cosine theta. It'd be very similar to the idea of if you had a problem that was like 1 plus x and then 1 minus x. You'd have to use the LCD of 1 plus x, 1 minus x. So it's a very similar idea to going back to that algebra. So for the first group, I'm going to multiply by 1 minus cosine theta over 1 minus cosine theta. And then for the second group, I multiply by 1 plus. So I multiply, remember, by what I'm missing. And I'm going to go ahead and clean this up. So here I would have just, so 1 times this doesn't, not going to change anything, 1 minus cosine theta. Now in your denominator, you are going to multiply that out. So I have 1 minus cosine theta plus cosine theta, and then minus cosine squared theta. And then here we're going to have almost the same thing, but 1 plus cosine theta on top. And then when you FOIL up the denominator, you get the same thing. Hopefully you're also noticing that that minus and plus cosine theta are going to cancel in each case. So you have 1 minus cosine theta plus 1 plus cosine theta. And that's all over 1 minus cosine squared theta. Now here I have a minus and a plus cosine that are going to end up canceling out. And 1 plus 1 is 2. And then the next thing I'm going to notice here, I'm going to remember my Pythagorean theorem. I see that square. So whenever I see squares, I start thinking about my Pythagorean theorems. And it's sine squared plus cosine squared equals 1. If I bring the cosine to the other side by subtraction, and we've seen this before, we do get sine squared equals 1 minus cosine squared theta. So I am going to go ahead and make that substitution here. And I have 2 over sine squared theta. Now, at this point, I can't really see much else to do. I'm trying to get to cotangent, right? So if you look here, I'm trying to get to cotangent. I see 2, so I'm like, oh, I have a 2 there. That's good, right? Try to get to cotangent, then I have sine squared, and I'm like, okay, well, sine squared, we know the Pythagorean theorem, but I just used that. I know sine is 1 over cosecant, so can I use that? But I don't really see how that relates to cotangent right now. So I kind of feel like I'm stuck. I'm not really sure where to go. It's pretty simplified. So here's an example where I have taken the left side of the equation kind of as far as I can go. I really can't think of anything else at this point, but it doesn't match the right side yet. So here's where we employ a new strategy. We're now going to take the right side. We're going to take the right side instead as far as we can go. And we're going to hope that they meet and they match somewhere along the way. So let me try that. Let's try the right side. Okay. So I'm going to go ahead and start with 2 plus 2 cotangent squared theta. All right, so the left side didn't get me the whole way. I kind of only got part way and I got stuck. So I'm going to try the right side now. And I'm going to see what I can do with the right side. Now, there's different things you can do here with that cotangent squared theta. So you could use the Pythagorean identity here. You could try that. You could also use the idea that cotangent is cosine over sine. I'm going to go with that one, but again, there's often more than one way you can do things. So go with whatever you see and see if that works. So remember, cotangent is 1 over tangent, but it's also cosine over sine. And again, usually we like to put things in terms of cosines and sines. So I'm going to use this one. And you may be saying, yeah, but it's squared. That's okay. What I'm going to do instead is I'm going to use cosine squared theta or sine squared theta. So I can go ahead and still use those reciprocal rules. But if it's squared, I'm going to have to use the square there as well. So you can still apply them. All right, so what I have then is 2 plus 2 cosine squared theta or sine squared theta. I see adding here, I see fractions. So my next step is maybe let's try a common denominator. So for the first one, my denominator should be sine squared. So I'm going to multiply by sine squared over sine squared. And when I do that, I get 2 sine squared theta plus 2 cosine squared theta all over sine squared theta. Well, I do see at 2 I can factor out here, and then I get sine squared theta plus cosine squared theta. Remember that this right here is one of the Pythagorean identities. Sine squared plus cosine squared of the same angle is 1. So this becomes 2 times 1 over sine squared theta, or 2 over sine squared theta. All right, and again, I'm like, okay, I'm stuck. I did not get the left side. But notice what happened. When I simplified the left side, I came to 2 sine squared theta. And when I simplified the right side, I also came to 2 sine squared theta. Because these are the same, they're equal, we actually did prove the identity. So I know this one's a little tricky, right? Because you're like, yeah, but you didn't totally match. But what happened is I matched something else. So I was able to manipulate the left side, and I got down to 2 over sine squared theta. I was able to manipulate the right side. I got down to 2 over sine squared theta. These are obviously the same. So that means that there's a commonality between the two sides. I was able to manipulate each side independently and come to the same thing that is truly equal. So I am done. So typically we try to show that one side is equal to the other side. That usually works. For some that are really complicated, we may not be able to get there. Or maybe we can get there, I just can't see it, right? I'm sure there's some way I could get there. I actually could like reverse this process and go backwards. but it wasn't obvious to me. But by trying each side, I was able to find something that was the same. So this is another strategy that you can use for verifying identities. Again, it's not my favorite. I usually try to just do one side and focus on that. But if you're stuck, you can do the left side first, do the right side separately, and then see if you can get them to match. But you do want to manipulate them separately, one at a time, as you do that strategy.